So here we have to show that this function that we have 4 over pi times 1 over 1 plus x square is a density function of a continuous probability distribution. So where x ranges from 1 to infinity. So first note that the function is greater than or equal to 0, and actually the function is strictly greater than 0. So it's even better. And then we have to show that the value of this improper integral is going to be how much? 1. So let's begin with that. So we can write this integral for evaluation purpose as integral of 1 over 1 plus x squared. I forgot writing dx, okay? From 1 to alpha, as alpha goes to infinity. First we have to evaluate that. So let's do this here. So if I do this, we know that the antiderivative of 1 over 1 plus x squared is tangent inverse x. And this is from 1 to alpha. So what we get is that the value is tangent of alpha minus tangent inverse of alpha minus tangent inverse of 1. So this is tangent inverse of alpha, and tangent inverse of 1 is how much? That's pi over 4. Okay. So now we know that this value tangent inverse of alpha as alpha goes to infinity is pi over 2. Therefore the total value is pi over 2 minus pi over 4, which ends up becoming pi over 4. And when you multiply this pi over 4 by this 4 over pi, the product will become 1. So if we have this graph of f, then this yellow region, going from 1 to infinity is going to be how much? 1. Now say you have to find out that what is the probability that x takes on a value between say 1 and 3, that is this blue region. All that you have to do is that you shall take the integral from 1 to 3 of f, which is going to be 4 over pi times 1 over 3, 1 over 1 plus x squared dx. And that is, as you just saw, 4 over pi tangent inverse 3, and at 1 it will become pi over 4. Or in general, say for any point, say L here, okay, or in other words, say we want to find this red area, then what the value will be? The value will be the integral from 1 to L, that of fx dx, and that will be 4 over pi inverse tangent L minus pi over 4. So this red area here equals this quantity, all right? Now say we have to find the median of this distribution. That is the value m such that the area to the left of m is 0.5 as well as to the right of m is 0.5. So in other words, this orange area is how much? That is simply 0.5. So that's what we have to find. So what we are going to do now is we shall look at integral from 1 to m, 4 over pi, 1 over 1 plus x squared dx, and we just evaluated it. So we are doing it again and again. So this is tangent inverse m minus pi over 4. And what do we need this whole thing to be? We need this to be 4 over pi and then tangent inverse m minus pi over 4. We need this value to be 0.5. Okay, so now I just typed it up because otherwise my old hands are not cooperating in handwriting. So this is, if we distribute it, this becomes 4 over pi tangent inverse m, and this is reciprocal of this quantity, so that should simply be 1. And let's just write it also a little more precisely. So what we got now is that we got this equals how much? 1 plus 1 over 2, which is 3 over 2. Okay. And then what will, so this is 3 over 2. Okay. 3. And so that means tangent inverse m is how much? If we multiply by that reciprocal, this will become 3 pi over 8. Okay, so m will be how much? M is simply going to be then tangent of 3 pi over 8, right? Okay, so it is tangent of 3 pi over 8, and we'll just go ahead and take an approximate value from our calculator. So I'm just using this Desmos calculator, changed it to radians, and then what we want to find is this. What is the value of 3 pi, okay, over, where is the over sign, over 8. All right, and it gives us the value as 2.4142. Okay, or if you would like, you may just play with your trig identities, just the half angle formulas and difference of the angles for tangent formulas, and you can find the exact value whichever way you please. Okay, so this is approximate value, this is exact value for the median of that distribution. Okay, and say if you have to find, for instance, the first quartile of this, all that you got to do is, and again we are just looking for the approximate value. So say we want the Q1 here, right? So for Q1 or the first quartile, this area has to be 1/4, and then you can go ahead and solve for Q1 the same way. Okay.